Welcome back to the Explainer. So if you're a developer who's using AI to help write code right now, you already know that having visibility into what your AI is actually doing is, well, absolutely crucial. Today, we're diving into a massive point of friction that just recently blew up in the AI coding community, specifically around Claude Code and its suddenly missing terminal logs. We're going to break down the problem, the completely understandable community backlash, and most importantly, we'll look at a really incredible open source solution that literally brings all your data back into the light. Let's get right into it. Let's kick things off with a quote from the tech blog Symmetry Breaking that perfectly captures the current vibe. They wrote, "Read 3 files. Which files? Doesn't matter. You're paying $200 a month for a tool that now hides what it's doing with your codebase by default." I mean, they hit the nail on the head, right? This perfectly summarizes the massive headache developers ran into right after the fateful version 2.1.20 update of Claude Code. Basically, overnight, users just lost all granular visibility. Detailed terminal outputs were swapped out for these super opaque one-line summaries that pretty much left everyone guessing. Look at this comparison. By default, Anthropic now hands you a virtually useless summary that just says something like, edited 2 files. Okay. But no file paths, no content, no line numbers? What developers actually need to do their jobs are visual, inline diffs with exact added and removed highlighting. It's pretty simple. You literally cannot debug AI code if you have no idea what the AI actually changed. Now, when developers rightfully complained about this over on GitHub, Anthropic's official response was essentially, hey, just use verbose mode. But honestly, verbose mode is a total trap. It's not a targeted solution at all, it's a fire hose. If you actually turn on the -verbose flag, you just get these massive dumps of raw JSON payloads. It is absolute nightmare fuel when you're just trying to track down a simple bug. You get internal system prompts mixed in with your own data, plus these massive unstructured sub-agent transcripts. It almost instantly turns into thousands of lines of completely unreadable noise on your terminal. Developers didn't want a massive data dump, they just wanted their inline file paths back. Section 5. Enter claude-devtools, the open source visual debugger. So because the official channels weren't offering a good middle ground, developer Matt1398 stepped up and built this completely free, zero-wrapper application that brings back total visibility without all the noise. And the architecture is brilliant. Step 1. Claude Code naturally writes its structured session transcripts to a local /.claude/directory on your machine. Step 2. This DevTools application simply reads those existing local logs directly. And step 3, the visual UI reconstructs everything retroactively. What's so cool about this is it doesn't intercept your API keys, it doesn't modify the Claude Code binary at all, and it actually works with every single session you've ever run, even from before you installed the tool. Section 7. Reconstructing the context window. Seeing exactly where your tokens go. If you've used Claude Code lately, you've definitely stared at that really opaque 3-segment progress bar in the terminal, just wondering what on earth is eating up all your tokens. Well, this tool solves that mystery entirely. You actually get per-turn token attribution mapped across 7 very specific categories. You see exactly how many tokens are being burned on your Claude.md rules, your active skills, the specific files you mentioned, tool inputs and outputs, Claude's extended thinking process, team overhead for agent coordination, and finally, your own raw user text. It just takes all the guesswork out of managing your context limits. And building right on top of that, the tool gives you compaction visualization. Basically, this feature tracks how your context window fills up, how it compresses when you hit those hard limits, and how it refills. This is a huge deal for developers. It finally answers that incredibly frustrating question, why did my AI's context just compact mid-task, and what specific instructions did it forget? You get to see the exact moment your data drops off, so you can actually adjust your workflow to fix it. Section 10. Inspecting subagents and tools, revealing the hidden execution trees. You know how when Claude spawns agents, and then those agents spawn other agents? The terminal usually just shows you the nicely polished final result. Well, DevTools actually renders the full, nested execution trees for every single sub-agent. You can finally trace the distinct tool executions, see the exact token metrics, measure the duration of the task, and, this is key, calculate the total cost for each individual sub-agent. That kind of granular cost auditing and performance tracking is completely invisible in the standard terminal view. Here's a great way to put it into perspective. A standard terminal summary just gives you a vague ran bash command, but over in the DevTools inspector, you get the syntax highlighted inputs and the full bash output. Look, if your AI makes a bad decision, you have to know why. Inspecting the actual inputs and the actual results returned by these tools is the only real way to trace exactly which file contents misled Claude in the first place. On top of all that, you get these highly customizable system notifications to actively monitor your AI's behavior in real time. So you can set it to trigger an alert if Claude tries to read your .env file, or if a tool execution throws an error, or if you hit a high token usage threshold. You can even set up custom regex triggers for sensitive paths. So if the AI decides it wants to read, say, your company's sensitive billing files, you are notified instantly. Section 14. Secure local architecture, deployment, and isolation. So how do you actually get this running? Let's talk about deploying this TypeScript codebase, which, by the way, is very actively maintained. It recently hit version 0.4.15 and already has over 3,300 stars on GitHub. The installation is totally frictionless. You've got flexible options. You can use Homebrew with a quick command on macOS, use direct downloads for Mac, Windows, and Linux, spin it up instantly via Docker with Docker Compose Up, or just run it as a standalone Node.js server. Zero configuration required, no messing with settings files, and it works seamlessly across all major operating systems. And for the enterprise teams tuning in, the most important metric on this slide is absolutely zero. The standalone Docker deployment makes exactly 0 outbound network calls. Everything stays right there on your machine. It simply reads your local directory and serves the UI straight to your local host, so you get maximum security and complete data isolation. Which brings us to our final slide, and really the ultimate question we have to ask. Are you still letting your AI code blind, or are you ready to see everything it's actually doing to your codebase? Hopefully this explainer has shown you just how critical it is to move beyond those opaque terminal summaries. By simply tapping into the logs that are already sitting on your machine, you can take back complete control and visibility over your AI coding tools. Thanks so much for joining me for this explainer, and hey, happy debugging!